and putting them in order, comparing them to one another. So this will be our first introduction. We're going to be doing a lot more work with decimals over the next couple of weeks. For today, we're going to be looking at plotting the decimals on a number line, comparing and ordering decimal values, and comparing fractions and decimals using a number line. But in order to get you there, let's go ahead and start with the review. We're needing to write each decimal in expanded form. So let's see who remembers that one from elementary school. If you don't know what expanded form is, talk to those at your table. So your first one should have been really easy. I have 2 100s. I have 4 10s. I have 0 1s. I have 1 1/10. And I have 2 100s. Okay? Our second one, we have 5 1s. I have 0 10ths. And I have 6 100s. Yes. Parentheses counts as long as you have the plus sign in between. Okay. Everybody good on that? Okay. So we actually have a challenge for you today. Recall, I can write decimals to represent fractions. The decimals are based on denominators of tens for the place values. So tens, hundreds, thousands, 10,000s, etc. Goes on forever. Steve saw this advertisement right here for a water bottle outside a convenience store. He went in, he handed the cashier a penny to pay for his bottle of water. The cashier told him it wasn't enough. Who is correct? So I'll let you guys talk about this as a table, but try to figure out, is Steve right that he could pay a penny for this water bottle? Or is the cashier right? He needs more money. Okay, how many of you guys feel that Steve is correct on this one? Seriously? Liam, you think Steve's correct? Well, that's the next question. How many of you think the cashier is correct? Everybody thinks the cashier is correct? Hold on. Guys, one at a time. Sophia?
Okay, so...
Good, explain your reasoning.
Yes. So a penny, to make $1 or 99 cents, you need 99 pennies to get enough for the water bottle, because a penny is only like 1 cent. 1 over 100. But if he had like $1 or like 4 quarters, he could pay for it and then get a penny back. So the cashier is correct because this dude doesn't know anything.
Oh, so you're really just like the cashier.
Because the penny won't make it.
You didn't pay attention to the sign.
What? It says 99 cents.
Does it?
Yes, it does. 99 cents. What? It says 0.99 cents. John, a penny so? 1 cent. Wait, what? No, decimal. Decimal. Would it still be right? No. Wait.
Hold on, guys, one at a time. Guys, one at a time. Jet. One at a time, guys. Jet. That was it? So you also didn't pay attention to the sign.
What? So here more. There is no way more.
Hold on. Guys, 5. Thank you. Austin. Oh, I like that. So you're saying also that Steve is wrong. Well said. So Austin feels Steve should get a different career because he got a problem wrong.
No.
Billy, guys, Billy, Lauren. Okay. Wait, hold on. Lauren is saying Steve was right. Guys, quiet. Let Lauren explain. This is interesting. I have told you multiple times. I even gave you guys a warning. I didn't give A2 because I said pay attention to the sign, because what did the sign say? How much of a cent did they say that it cost? Of a cent. So if I give 1 cent and it only costs 0.99 or 99 hundredths of a cent, did he give enough money? Guys, one at a time. We can't understand anything when everybody's hollering. Guys, stop. Leanne.
Nobody has money like that because the decimal is there. Because if you have like pennies or like quarters, that and you have multiple of those, that makes up the dollar. If it was not, what about tax? Nobody counts money like this. Oh, your water bottle is going to be this penny cut into 99 small pieces.
But that's what the sign said. Okay, Leanne actually made the most intelligent statement so far. She said the story is stupid. Okay? I would actually be tempted to agree with her, because if the story had been intelligent, they would have done their notation properly, and they would have made the sign look like that, wouldn't they? Does that make a difference? Absolutely makes a difference. Guys, listen up. Here is why I have tried to stress to you guys so much this year that your units matter. When I am talking about cents and it say the water bottle costs 99 hundredths of a cent, Steve was right. Because he gave her a whole cent, it only cost 99 hundredths of a cent. Now, in U.S. denominations, guys, stop. In U.S. denominations, we don't break pennies into smaller pieces. So the store did their sign incorrectly. Steve was correct. Okay?
You're like $3 now. Yeah, what about homeless people? Need water. Need water.
Guys, one at a time, please. You guys are not doing well today. We're going to have to go to state silence so that people can hear. 5, please. It's the last day of the quarter. Don't make me end with yelling at everybody. Lauren. .01. She can't, so he wouldn't get change. But if I'm getting a water bottle for a penny, am I really going to whine that I'm not getting change on it?
Yes.
No.
I would. I still get change.
Okay. Now, just so you guys understand, if this were real life and the advertisement said this, they would be forced to sell him the water bottle for a penny. Yes, it's called false advertising. If they make a mistake in their advertising, they have to hold up to it. At least until the point that it is noticed, and then they can put out a correction. And once I've done a correction, then I no longer have to do it. But until it is brought to their attention, they have to honor their advertisement. Callie?
So basically, you're saying that cent, it has a C instead of the S. Cent. So a penny is is 1/10 or 1/100.
A penny is 1/100th of a dollar,
So
but they use the unit of cents in their advertisements.
so this is something I have a question that I've never been had no one has answered in my entire life.
Okay?
Starting from when I worked with money. What is the difference between a dollar sign and a cent?
A dollar sign talks about a dollar. So that's the bill that you normally get, equivalent to 100 cents. A cent is a penny. So if I say 1 cent, I'm talking about a penny, which is 1/100th of a dollar.
So if it says 99 cents.
That would be 99 pennies.
What is the difference when you put the dollar sign on this? Than the cent?
It's a huge difference. It's a difference between a dollar bill and a penny. So $1 equals a dollar bill. 1 cent equals a penny.
So what would 99 cents equal?
99 cents would be either 99% of a dollar, or I would put 99 cents is 99 cents. So that's two different ways to display 99 cents. Either with a decimal and a dollar sign, because it's 99/100ths of a dollar, or 99 cents with a cent sign.
So basically the store meant to like say that it was 99% of a dollar.
No, that's what they meant to say, but because they used the cent sign instead of the dollar sign, they were wrong. Because 99/100ths of a cent means it's less than 1 penny.
So 99% is less than 1 penny?
99/100ths of a cent is less than a penny. Okay, guys, we have to keep moving on because we got a lot more to do today. But our next part, I'm going to have you do both of these at once. Consider the representations for the cost of each item. Circle the correct representations. If it's not correct, state why not. So you have to answer on every one. It'll either be circled because they're right, or you write out why they were wrong. So you're going to do that for all 8 of those items. So an item A costs $1.50. Is that $1 1/2? Yes. Is that 1 1/2 cent? No. What's wrong there?
So it's basically saying 1 penny and half of a penny.
Okay.
Because it's cents.
So they used the wrong units. It's like what they did in the question before. If I use the wrong units, I get the wrong answer. What about $1.50? Yes. What about $1 1/50 of a cent? No. Again, they used the wrong units. And they use that notation with the dollar sign, they would have been correct. Our second set of numbers. This one is just $1. Is that $1? Yes. Is that 100 cents? Yes. Is that a dollar with 2 decimals? Yes. Is that 1 with the cent sign? No. Again, what'd they do wrong? Wrong units. Yes, your units matters, guys. If I don't have the correct units, I'm going to get the wrong answer. So it's not only critical in area and volume, it's also critical in money. Okay, decimals are valuable when you need more precision for measurements between whole numbers. The decimal point in a number separates the whole part of the number from the fractional part. The digits following the decimal point represent a value less than 1. So I do want your highlighters out. We're going to do this meaning real quick. We have in math different sets of numbers. One of the important ones that we use most commonly, you guys have been using this since you were in kindergarten, is what we call rational numbers. A rational number, it can be represented in the form a over b, where b is not equal to 0. That is important. I can't divide a number by 0. But if I can write it as a fraction, that makes it a rational number. So if I can write it as a decimal, I can write any decimal as a fraction, then it is a rational number. One that always gets really confusing is where we get what we call repeating decimals. So just as we said earlier, if I have a fraction like 1/3, okay, and we just talked about this earlier, my winner, the top guy, goes in the house, so I'm doing 1 divided by 3. Will 3 go into 1? No. So I added decimal and a 0. How many times will 3 go into 10? 3. So I subtract 9, I get a 1, I bring down another 0, and I have 10. Uh-oh, I just saw that, didn't I? It's going to be the same thing forever, isn't it? So who knows how we annotate that?
Well, you can just go 3 or 0 point or and 3 3 3 and then you're done.
Nope. Good. I use what's called bar notation. So when I see a letter, a decimal that's going to repeat forever, which happens quite frequently, believe it or not, all I do is I put a bar over the part that is repeating. That's called bar notation. That just signifies this is the decimal with that 3 that goes on forever. So a lot of students are like, well, how is that rational? Because I can represent it as a fraction. That is a fraction 1/3. Does that make sense? Okay? So rational numbers are ones I can represent as a fraction. The fractions can be turned to decimals. Sometimes they're repeating decimals. So if I'm doing math with it, a lot of times it's better to do it with fractions because a repeating decimal I can't really do the math with. Yes, Austin?
Fractions, you do like 0.01 out of 0.06. Oh,
You can. It'd be 1/10 divided by 1/6. Yeah, you can. Okay, we're not going to do number 1 due to time constraints. It's almost lunchtime. But before lunch, I do want you guys to do number 2. Just as an example, I will do part A for you. So if I look at my number line, I can see from 0 to 1, there's 10 spaces. That means that every one of those is 1/10. Make sense?
Yeah.
So for 2500ths, I need to go to the 2/10. But then the 5 says I'm halfway between there and the 3/10. So I put that dot directly on my number line where it would be, and then above it I put the letter that it represents. That is how I plot a point. Okay? So you're going to do that for every single one of these. You've got 8 of them, or you have 7 more to plot, and you got about 3 minutes. Go ahead and go. So looking at these points, point B, 1 in 3800ths. So I'm going to the 1. I know already it's in tenths, so 2, 3, almost to the 4. So B would be right around here. C, 5/10. That's between 0 and 1. 1, 2, 3, 4, 5. There is C. D, 2 and 3/10. So 2, 1, 2, 3. That one's right on that point. That makes that one easy as well. 5600ths gets a little more tricky. So it's just past the point 5 and just halfway, a little over halfway past that one. So E is right next to C. D, 2 and 9200ths. That gets us almost to the 3. So there's F. G, 1 and 7500ths. So 1 and 7500ths gives us G. And our last one, H, 1 and 1/10. So once we have the points plotted, this is actually a really good way for us to determine which points are smaller, which are larger. How do you tell on a number line which number has the greatest value? You're on the right track. I don't like your wording, because that was very specific to this one number line. On a number line, how do I know when a number is larger? Or how do I know when it's smaller?
If it's like the same number, then you have to look at the other side to see if there's more or less.
Okay, but on a number line. Jaden? Okay, you guys are also talking about the numbers. I want just a generic rule for a number line. Tita? Is the what? Awesome. That's what we're looking for. So I'm going to give you a couple phrases. One is left is least. So left is the furthest left is the smallest, or right is biggest. So I don't want you to think in terms of zeros or in terms of the numbers on the lines. Just get this thought in your head. If I'm on a number line, the one furthest left is least or smallest. The one furthest right is largest. So when we're comparing numbers, that's really all we're doing. It's saying on the number line, is it further left or further right? That tells me bigger or smaller. Okay? So how can I use a number line to compare numbers? Using those rules. So if you didn't write those rules down yet, please make sure you do. Everybody good? Let's go ahead and turn the page. Yeah, but she continued writing, and then once around her have it. So we're going to have you guys do this page as a table. I'm going to give you guys 5 minutes to do the 4 questions on this page. If you finish, you can go ahead and start on the next one. Okay, analyzing the number line. We had several directions. Again, marking your text is going to help you out immensely. Please start marking your text. I got way too many of you not marking your text yet, Austin. Okay? If you'll mark your text, it's going to help you understand everything you need to do. So label each tick mark on the number line with the decimal value it represents. Then plot points to represent 3/10 and 4/10. So I need to do this and this. When I look at it, I have 5 marks to get to 2500ths. So I take the 2500ths, I divide it by 5, and that gives me 500ths. So each mark is 500ths. 1/10, 1500ths, 2/10, 3/10, 3500ths, 4/10, 4500ths. Now we have them all marked. Now I need to plot the 2 points, 3/10. So that one's going to go right on the number line here. And 4/10. That one's going to go right on the number line here. Plot and label 4 points that represent decimals between 3/10 and 4/10. So it's saying I need to have 4 different intervals in between 3/10 and 4/10. So I'm going to go with 3200ths. So that's a 3. Actually, they already gave us 3500ths, so we'll use that one. We'll go with 3600ths, which is right after it. And 3800ths, just to give us enough room to write them in there. So you could have done any 4, but you should have 4 different plots pointed in between those 2 areas. So it had to be somewhere in there. Now, write 4 decimals between 4500ths and 4600ths. So I would assume most of you did something to this effect. 451 thousandths, 453 thousandths, 457 thousandths, and 458 thousandths. Doesn't have to be those numbers. Technically, I could have done 451 hundredths and then 4,512 10,000ths. That would also work. The bottom line, all of your numbers should have a 0.45 to start. Yes? Sure.
4, 5, 3, 1, 8.
Except you didn't say that properly.
I don't even know how to.
Well, then maybe you should have written it or volunteered to say it.
It does work. I mean, it works, but like.
It works if you say it properly. Yes. Guys, quiet.
Why did you put? Oh, this had me dying. You put. Wait. Never mind. You put so much order. You put 5.
Which part was confusing you?
The front part, because when it said like 3 and 4, I put it at the front, but you put it here, and I don't know why.
What did you do? Let me see.
Like I put it here.
So you're saying that 4/10 comes on the number line before 2500s.
No.
That's what I see.
Well, I'm sorry, I did not mean that.
Do you understand why I did what I did? Okay. Liam. Let's work on what we're working on right now, okay? So now, you're babysitting your neighbor Remley, who's in the 4th grade. Remley is doing her homework and asks you whether her work is correct. So she gave us 4. We're going to vote on which ones you think are right. Did she do number 1 correctly?
Yes.
Raise your hand if you think she did. So Liam, you don't think she did that right? You're supposed to be with us right now. You know where we're at? Okay, so did Remley get number 1 right? Right, but that's why you're supposed to be with us right now in class. Homework's done outside of class. So yes, number 1, she was correct. What about number 2? Raise your hand if you think she's correct. So we all agree it should have been 4/10. Okay, number 3, raise your hand if you think she's correct. So an easy way to do that would be, as I heard a few people say, make the same place values. So 60 hundredths is bigger than 9 hundredths, right? So that one she was wrong. It should have been here. What about for number 4? Raise your hand if you think she's right. Okay, what do you have to say, Austin? Why? Any whole number is bigger than any decimal. Okay? So if it's a whole number, it will always be bigger than any decimal, regardless of how many 9s there are. Jet? Yeah, she missed 3 out of the 4, right? Okay? So write a rule that determines how to determine when a decimal is greater than another decimal. That's the same rules we just used, right? If I'm looking greater than, further right is greater. Explain to Remley whether or not her homework is correct and instruct her on how to correct any incorrect answers. Like we did that as we were talking through it. Anybody have any questions on any of those 3 that we corrected? No. Okay, let's turn our page. Okay, unfortunately we're down to 6 minutes, so I want you guys to finish as much of this as you can. Actually, let's skip number 9. Let's just go to 10. I'd rather have you plot the points and then use the correct symbol. So we'll give you guys 2 minutes to get as many of those done as you can so we have time to go over the homework. 1. Okay, our first one, excuse me, 9/10. So this is built in tenths. So 71 hundredths will be 71 right here. 9/10 would be here. So that means 9/10 is greater. 15 hundredths, that's going to be 10, 15. 1/4 is the same as 25 hundredths. So there's 1/4. There is 15. I'm sorry, that's backwards. There's 15 hundredths. There's 1/4. So that's less. And that's all we have time for because we need to go over your homework. Excuse me. On page 125. please don't forget the journal entry. We had you highlight that definition earlier. So plot each on the decimal line. So it's the same as we just did in class. Make sure you pay attention to the intervals. Write 4 decimals. We did one very similar to that. Order the decimals. Again, pay attention to the ones values as well as the decimal values. On last page, compare greater than, less than, or equal to. And number 5, she recorded it. List them from least to greatest. So again, pay attention to both the ones digits as well as the decimals, and realize what order you're doing it in, least to greatest. So everybody should have that one torn out to take home. If you need it printed, I'll have it on the Google Classroom tonight.